Hi guys, so we're going to look at this topic which is work, energy and power. This is a topic in physics, that is science paper 1. Right, so we're going to start with the first one, which is work. Let's begin. So there it is. Work. How do we define work? Work is defined as the product of the force and distance moved in the direction of the force. So work is measured in the unit joules. So these are the SI units of work. Then we are saying to calculate work, we say work W, which would be measured in joules. Then the force here, we get the force in newtons. Then we get the distance in meters. So now let's look at one question where we can make a calculation on work. A force of 5 Newton acts on a brick, moving it 8 meters from rest. Find work done. Now I'm to write the data here. So the data is what we've been given. So I've been given force. So we've been given a force of 5 newtons. What else have we been given? We've been given distance of 8 meters. Alright, then work we don't have. So when there is work, we put question mark. Therefore, how can we find work? To find work, so I'm going to start. To find work, I'm going to say work is equal to the force multiplied by the distance. So now we have the force there and we have the distance. So what I'm going to do is I'll put the force. So we have the force, which is 5, and we have the distance, which is 8. So if we say 5 multiplied by 8, we're getting 40 joules. So the work here is 40 joules. That is how we can find work. Okay, now that has been done, we proceed. We look at a different concept. This is energy. How can we define energy? Energy is defined as the ability to do work. So we're saying the unit of energy is also joules. And under energy, we have two types of energy. We have potential energy and kinetic energy. So we start with the first one, which is potential energy. So what is potential energy? So we're saying potential energy, this is the energy by the position of an object. So this is the energy that an object possesses when it is at rest position. So to calculate potential energy, we're saying you need the mass, then the acceleration due to gravity, and the height. That is what is needed. Now let's look at an example. A 20 kilogram object is raised to a height of 5 meters. What is its potential energy? So data, we've been given mass, which is 20 kg. Then we have been given height, which is 5 meters. So what else have we been given? So g is a constant. G is acceleration due to gravity. So for g it is 10. So we use 10 for g, 10 meters per second square. Okay, then how do we find potential energy? So we are saying potential energy is given by mgh. So we start, what is the mass? The mass is 20, acceleration due to gravity is 10, then the height is 5. So 20 times 10 times 5, so 20 times 10, that is 200. and 200 multiplied by 5 we get 1000. So we have 1000 joules. So 1000 joules, that is what we get as our potential energy. Right, then we proceed, we look at kinetic energy. So we're saying kinetic energy, this is the energy due to the motion of an object. So an object that is moving possesses kinetic energy. So kinetic energy is found by saying half multiplied by mass multiplied by velocity squared. So now let us look at it in this way. We have a question there. A 2 kilogram stone is thrown with a velocity of 5 meters per second. What is its kinetic energy? Now we start with the data, what we have been given. So what we have a mass 2 kg. What else? We have the velocity 5 meters per second. Then what else do we have? So we're looking for kinetic energy and we don't have it. So I'm going to say kinetic energy is given by half mv squared. Kinetic energy is equal to half multiplied by the mass. M is a mass, which is 2, then the velocity is 5, then squared. So I'm going to say half is the same as 0.5 multiplied by 2 multiplied by 5 squared, that is 25. So if you say 0.5 multiplied by 2, we get 1, and 1 multiplied by 25, we get 25 joules. So 25 joules is the kinetic energy for this one. Now we're going to proceed and we look at what we call the law of conservation of energy. So conservation of energy, so this is a law. So we're looking at the law of conservation of energy, and this is what it is stating. It says that energy cannot be created or destroyed, but can be changed from one form to another. Now let's look at these two examples. Look at a falling object and a simple pendulum. So we have a stone here. Before it is thrown down, the energy that it is possessing is called potential energy, and it has zero kinetic energy. So as you can see, suppose the energy was 10 joules, so it means the energy it is possessing, all of it is a potential energy. Once it has been released to the atmosphere, when it starts moving, the potential energy will start being converted to kinetic energy, and it's going to reach at the middle. So at this middle point, the potential energy and the kinetic energy will be the same. So potential energy will be equal to the kinetic energy, that is they're going to be half. So the total energy was 10 joules, so it becomes half here. Half of 10 is 5, so potential energy is 5 joules, kinetic energy is 5 joules. Then just before reaching the ground here, all the potential energy is converted to kinetic energy. So as you can see, we started with 10 joules and we have ended with 10 joules. So energy is neither created nor destroyed, but it is just being converted from one form to the next. Look at a pendulum on this other end. So when you have a pendulum bob here at the first position, which has not been released, the total amount of energy it is having is potential energy with zero kinetic energy. Once you release it and it reaches on the middle, all the potential energy becomes kinetic energy, and once it goes to the end, all the kinetic energy becomes potential energy. So that is how you can look at the law of conservation of energy. Alright, so now lastly we're going to look at something else, which is called power. So that's the last subtopic. Look at power. So what is power? Power is defined as the rate of doing work. So we're saying power can be measured by saying work done over time taken, or we can say the energy, because both work and energy are measured in joules. So the energy over the time taken. Let's look at an example. A crane can lift 200 kilograms to a height of 10 meters in 20 seconds. What is the useful power of the crane? As usual, we're going to start with the data, then we're going to proceed to solving that question. So on the data, what do we have? So we have a mass. So let's say data here. We have a mass of 200 kilograms. We have a height, which is a distance of 400 meters. Then we have time of 20 seconds. So now the question we're looking for power. So remember we said power is equal to, so power is equal to the work done over the time taken. Now how can we find the work which is done here? So to find the work done, because time we have but we don't have work, so firstly what I'm going to do, I'll find work. Now the work I'm going to find will be, since will be in form of weight, so I'm going to say weight is equal to mg. I hope you remember this formula where we say weight is equal to mass times gravity. So where here we're going to say we have, okay, so now we're going to say we have that the mass is 200, then the gravity is what? So the gravity is acceleration due to gravity, it's a constant, so that one is 10. So 200 by 10 becomes 2000 newtons. Now what we have found is called weight, so don't make a mistake. We have found weight, so this is the weight. But what we're looking for, we want to find work. How can we find the work? Work can be found by saying force times distance. So the force in this case is the weight we found, because force is measured in newtons. So the force is 2000. Then the distance, which is the height, is 100. So when we say 2000 multiplied by 100, we get 200,000, and the SI unit is joules. Now that we have found the work, we can now finally go back to find the power. So we said power is equal to work done over the time taken. So here we are saying the work done is what? So the work done is 200,000. Then the time taken is 20. So this is 200,000 joules, 20 seconds. So 20 into 200,000. So 20 to 200,000, it goes there 10,000 times. So 10,000. And what is the SI unit of power? Power is measured in watts. So you say W. So power is measured in watts. So that is how you can go about that. I hope all is clear. Now I'm going to give an exercise that you can try out. So just put a question that you can try out. That is a simple exercise that you can try out.